All right, hello everybody. We are back again to Amazing Math with Miss Lastly. I don't know why I keep saying that. I really should have made a better catchphrase for these videos. If you watched the video from last class, which if you're in person, you definitely did. If you weren't in person, then hopefully you did, but you'll notice that I have the same cool outfit and ridiculous hairstyle. It's because it's the same night, Saturday. Now it's 9:48 p.m. So we're really working into the nighttime. Some of you probably go to sleep later than this, but I don't. My bedtime is usually 9 o'clock. So I'm a little tired. That's okay. Let's get started on our video. So today we are on day 2, law of cosines, which is, I think, just as easy as law of sines. I guess there are some parts to the law of cosine that can be a little weird, but I don't know. It's easy. They're all easy. It's way easier when you compare it to the last unit that we had, so you should be grateful. Here we go. Okay, so law of cosines. Now, why are we learning a second technique, Miss Leslie? We just learned law of sines. It seemed to have worked just fine. Well, something you might have picked up on in your homework is that there were only two types of triangles, like information that you were given. And this is probably something that you haven't thought of since geometry, and you probably hoped you never would have to think of again. But in geometry, you had what we call like postulates, and there were a handful of them, and some theorems, right? They were like side, 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 angle, angle, side, blah, 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 whatever, those things. Well, we're not technically using those because those were for like making sure triangles were congruent to each other or similar to each other. And we're not really doing that. We're solving. But the information is actually important. So on your law of sines homework, you were only given ones that would work with law of sines. But there are some times, so if you think about it, right? So if you're doing the law of sines and you don't know any side lengths, you can't do the law of sines. You need at least one side length, all right? So that's kind of an issue. Well, law of cosines has its own limitations, but it can help you solve some of the triangles the law of sines could not do, such as a triangle when you're given only only sides, no angles. Whereas law of sines, you need at least one angle, right? You need at least one angle and you need at least one side. Well, with law of cosines, you don't need to know an angle. You can find the side lengths without knowing any of the angles. Um, um, or you can find the angles if you only know sides. I guess that's better what I probably should have said. But yeah, so some instances you're going to find that using the law of sines is easier. Some instances you're going to find that using the law of cosines is easier. It's all about what information you're given. And so here, let's just kind of look at the law of cosines. So it's not the same kind of setup as the law of sines. It's not like a proportion where you have like a fraction equal to a fraction equal to a fraction. It's actually like an equation. So here's our triangle. So let's just sketch a triangle out. All right, so A, B, C. And then we talked about this last video. The sides across from the angles are just lowercase. So there we go. Okay, so we're not going to derive the law of cosines. We could. It's just really lengthy, and I just, you know, it's not really that important to derive them. We derived the law of sines, and that was fun. Law of cosines takes longer, so if you're interested, let me know, and maybe we can do it together. But it's a bit long. Okay, so I'm just going to tell you what it is. So the law of cosines looks like this. So a squared equals b squared plus c squared minus 2a times c cosine of angle A. All right, so it doesn't matter which, like, you can set this up. So there's obviously like 3 different equations you could write for this, but they all follow the same pattern. All right, the main thing is, all right, the side that you have over here by itself is the angle that you're going to have inside your cosine. And then the other 2 sides, they're going to be squared, added together, and then, so like the other 2 sides always go like right here and are squared and added together, and then they'll go right here, the A and the C. All right, so this is the pattern. So if, say, we wanted to do side B by itself, we would have b squared equals a squared plus c squared minus 2ac. This is wrong. I did this wrong. It's late. Cut me some slack. This should be a b. I was just doing my alphabet. Should be b. It should be b squared c squared and then b times c. That is what it should be. Just like I'm doing this one right. I don't know why I wrote that one wrong. It's my brain. It's late, guys. It's past my bedtime. All right, so b squared equals a squared plus c squared minus 2ac cosine of b. All right, so we have the b here, the angle b here. All right, and then we have the a and the c and the a and the c. So this is like our pattern, right? So just to finish it off, if we wanted side c to be by itself, it would be c squared equals a, oh, Jesus, it's so late. A squared plus b squared minus 2ab cosine c. So again, right, we have c, c, and then a and b go right there. All right, so that's the pattern. Now, obviously, the letters could change, right? You could have a triangle with letters J, L, and K, but this is the pattern for that law of cosine. All right, so here's the big question. When would you use law of sines versus law of cosines? All right, so law of sines, we kind of talked about this a little bit, but this is when you would kind of use it. So thinking about those like side, 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 angle, side kind of things. Law of sines, oh, let's do, all right. Dun, dun, dun. So law of sines. All right, so when you're given a triangle, and this is the information you have. So if you're given two angles and a side, so angle, angle, side, and the side is not in between the angles. So angle, angle, side. This one we would use law of sines. So two angles, one side, law of sines. All right, you actually could also do angle, side, angle. All right, two angles, a side in between. This one works because the side in between, you can find its opposite angle, which is what you would need because we know that all three angles add up to 180. So you could use that. Now, there's another one that we did not go over with law of sines because it takes a couple days and we didn't really have time to go over it. But if you were given two sides and an angle, so side, side, angle, you actually could use the law of sines for this. This is something called the ambiguous case. So you guys are not going to go over it this year. It is pretty tedious. What happens when you are given side, side, and an angle, it actually creates two scenarios. Because we don't know the length of that missing side. And so you actually are going to have two answers for a triangle like this. We are not going to have any of these. You won't see this on your test. It shouldn't come up on any of the homeworks. I believe I took all of those problems out. But this one we could solve using the law of sines. It is a bit more extra work. Because like I said, it could create two possible triangles, which is not something really that we want to deal with. We don't have time to go over it this year. Sorry, guys. We don't have to, we're not covering it. But that is a possible law of sines type of problem. All right, and then the last one, all right, so for law of cosine. So that's it for law of sines. All right, you need to have a lot of angles to do the law of sines because remember you need an angle and its opposite side. All right, so you kind of need a lot of angles, right? Actually, I think you could also do side. Nope, you can't because you need a side and its opposite angle. Yeah, those are the only two. Okay. Just double checking. All right, so then law of cosines is going to be side, side, side. All right, and that's the big one, right? So if you know all three sides of the triangle, you actually can figure out what their angles are using this law of cosines, which is kind of nice. The other one you can do is side, angle, side. All right, so you can also figure out all the missing pieces, sides, and angles using law of cosines if you're given two sides in the in-between or included is what it's called, angle. And those are the only two. So if you have any other information in a triangle, you are kind of not going to be able to solve it. But truthfully, I think that's all the different combinations. You do need at least 3 pieces of information, as you can see from these ones. If you only know one side and one angle, or just 2 sides, and it's not a right triangle, you really can't do much else with it. So if it is a non-right triangle, you do need at least 3 pieces of information. Good news is in this test, I'm going to always give you at least 3 pieces of information. So you will be just fine for this class. All right, so let's take a look at a problem using our law of cosines. All right, so first off, I know that this is a law of cosines problem because I know 3 sides. I don't know any of my angles. So I can't use a law of sines because I would need an angle and I don't have one. So this is a law of cosines problem because I only know the 3 sides. Side, side, side. Okay. So at this point, it doesn't really matter where we start. You can just pick an angle that you want to solve for first because we don't know any of them. All right, so since we can pick whichever one we want, I generally like to start with the biggest angle. And you might be wondering, Miss Leslie, how do you know which angle is the biggest angle? Well, if you remember anything from geometry, you'll know that the biggest angle is across from the biggest side. And that just makes logical sense, right? If it has to open up wider to accommodate a longer side, it's obvious. So I'm going to solve for angle S. Okay, so if S is the one I'm solving for, right? So if we go back up to our law of cosines, that's the angle that, so that means that the angle that we are kind of isolating, that side is the one that's going to go by itself. All right, so we go down, and so if I'm solving for angle S, then the 19 is the one that's going to go by itself, the side that's going to go by itself. So it's going to look like this. 19 squared equals 18 squared plus 14 squared minus 2 times 18 times 14 times the cosine of S, which we don't know. All right, so I just need to solve this to get S by itself. All right, so I'm going to do 19 squared, so 361, 18 squared, 324, 14 squared, 196. All right, and then negative 2 times 18 times 14, so it's going to be minus 504 cosine of S. All right, so subtract 324. All right, so we have 361 minus 324. That's going to give us 37. So 37 equals 196 minus 504 cosine of S. Subtract 196. So 37 minus 196. So that's negative 159 equals negative 504 cosine S. Divide both sides by negative 504. All right, so divide negative 504. So that's going to give me 0.315476 cosine S. All right, now if I want to get the S by itself, I have to move the cosine, which means I'm going to do inverse cosine of both sides. So second cosine, and that's going to give me S equals 71.6. Now with angles, we want to round to the nearest degree. It's awkward to have an angle be a decimal, so we're going to say that this is 72 degrees. All right, so now we're going to pick another angle. Doesn't really matter. Since we did the biggest, why don't we just do the smallest? So let's go for 14. So let's do R next. Okay, so here we go. Let's do this one. All right, so we have 14 squared equals 18 squared minus 9 plus 19 squared minus 2 times 18 times 19 cosine of R. All right, now I'm going to do this a little bit faster. I'm not going to write out all the numbers. I'm just going to kind of use my calculator. So I'm going to do 14 squared. All right, I'm subtracting 18 squared, and I'm subtracting 19 squared. Then we don't have to do them separate. It does make it go by a lot faster. So 14 squared minus 18 squared minus 19 squared. And that's going to give me negative 489. All right, and then negative 2 times 18 times 19. That's negative 684 cosine R. So now I just divide both sides by negative 684. All right, divided by negative 684. And that gives me 0.71491 cosine R. All right, and now I'm gonna use inverse cosine so I can get angle R by itself. So I get R equals inverse cosine. And again, rounding to the nearest degree, that's gonna give me 44 degrees. So this is 44 degrees. Now, you don't have to do the law of cosines again because we can use the triangle rule that tells us all three angles have to add up to 180 to find angle T. So if we do 180 subtract 72 subtract 44, that's going to give us 64 for our missing angle. So angle T equals 64. Right? We did 180 minus 72 minus 44. There, just in case. All right. Well, that is it for the law of cosines. All right. A little bit different formula, but I don't think it's that bad. You just have to make sure that you put the numbers in the right places. Remember, the side that's by itself goes with the angle in the cosine. Your other sides go in the other places. That's the main thing that you want to make sure you match up when you're doing your law of cosines. All right, well, that is it. And now hopefully you guys will be able to work on your classwork. Bye.